let us discuss vector calculus. First of all, what is calculus? Calculus is a branch of mathematics that deals with the study of rates of changes and accumulation of quantities. Calculus is divided into two main branches, which is differential calculus and integral calculus. The differential calculus is a branch which focuses on concept of the derivative. Derivatives measure how a function changes as its input changes. The input is the independent variable. So imagine we have got a curve over here and x is independent variable. If we move from x to x plus delta x and we try to find out how the function f of x changes, that is called derivative of a function. The derivative of a function at a particular point represents the slope of the tangent line to the curve at that point. So the tangent line is shown in green. So mathematically, the tangent or the orientation of this tangent is written as f of x plus delta x, which is this green line, minus f of x. So we get the change in the y is equal to f of x direction. Divide that by the step, the small step which we have taken, which is delta x. So that gives us the tangent theta or the inclination of this tangent. In the case of calculus, we are normally interested in study of rate of changes. So for rate of change, we squeeze this delta x and we bring it to an infinitesimally small length. So that in the language of calculus means that we take a limit and make delta x almost equal to 0. It doesn't become 0, but it is very, very close to 0. This can be written as the differential df by dx. This is simple calculus or simple differential calculus. Since we have studied vector space, therefore, we want to define vectors in the same way as ordinary functions. These functions are scalar functions. We want to define vectors in our vector space in the same way. So the good news is that we can use the same calculus to formulate the concepts of vector calculus. For example, imagine we have 2 points on this curve. This curve is a function. One point is defined by a vector v of t and another point is defined as v of t plus delta t, which is at a distance delta t from the first point. This is similar to what we had previously. We were using delta x step. In the case of vectors, we can use the same delta x or we can use delta t. Now we can write the vector differential as the vector t plus delta t minus vt. So please note that v of t plus delta t is the resultant of vt and delta v. These both are vectors. So delta v will be equal to vt plus delta t minus the vector vt. And that's what is written over here. Divided by delta t, which is the step. So we are using the same concept as over here. The scalar function is divided by the step. This is the change in the vector function divided by the step. And then we make this step tend to 0. We get v dash t. The reason I have called it as v because it can be velocity. And v t plus delta t and vt can be displacements. Once we work out our vector differential at point t, we can write it in the form of 3 components. So from the scalar definition of differential, we have now come to a vector definition of differential. In case of structure mechanics, we are dealing with stresses. A stress is defined by a surface and the direction. So if we assume an element, a small area within this cube, we have the outward drawn normal of this element and we have a stress requiring particular direction. So the force which is causing this stress has got a particular direction. So we need two entities to define a stress at a particular surface. Therefore, it makes sense to multiply our function with another vector which is normal. Since both in stress and strain, surface, the outward drawn normal of a surface of interest is very important. So therefore, in our definition of differential, vector differential, we will introduce concept of normals. So we will say that this first vector, if we multiply that with a normal n plus, and this another vector which is negative, we multiply that with normal n minus, and we rewrite the numerator as shown over here. So essentially what we are saying is that this figure n plus is facing in positive x direction and n minus is facing in negative x direction. So in this equation, instead of writing minus f of x, we can say that it is multiplied with n minus, and we can make this minus as plus. And similarly multiply this first function with n plus because it is plus. So since in the first term we have the coefficient plus, we multiply the first term over here with vector n plus and the second term with n minus because the coefficient of the second term is negative. This is equivalent to dot products. When we multiply two vector, this is just like a dot product between two vector and the result is a scalar. So the result of these two would be a scalar. Similarly, result of these two would be a scalar. That scalar can be divided by delta t, which is a step, and then we can make delta t equal to 0. This is the reason that with the vector differential over here is written in form of magnitude. This vector can again be multiplied with the another unit vector which was in v dash t direction, and we can get it again in the form of components. These two vectors, when multiplied, they are called as flux. Please note, if we have got a vector and we dot product it with another vector, we get a scalar. So if a vector having three components is dot product with another vector with three components, we will get a scalar. Similarly, if we have got a tensor having 3 power 2 components and we dot product it with another tensor, we would get a vector. So that trend will be seen when we are working out gradients of scalars, vectors, and tensors. Now let us discuss integrations or integral calculus. Integral calculus deals with the concept of integration. Integration is the reverse process of differentiation. It is used to find accumulation of quantities such as the area under the curve or the total distance traveled. So we can see a curve over here, and the area under this curve will be worked out by integration. The integral of a function represents antiderivative of that function. So differentiation is inverse of integration. The inverse relation of and integration brings us to fundamental theorem of calculus. Fundamental theorem of calculus is a central result in calculus that connects the concept of differentiation and integration. It is actually split into two parts. The first is fundamental theorem of calculus part 1 relating differentiation and definite integral, while the second part, fundamental theorem of calculus, deals with the evaluation of definite integral using antiderivatives. let us try to understand what is antiderivative and how the fundamental theorem of calculus help us in finding integral of different functions. Imagine we have 2D system and we define a function which is in reality df by dx. So we have defined a differential of the function between interval a and b. So if we integrate this function which is df by dx times dx between a and b, we will get the value of the function at b minus the value of the function at a. In other words, if this is the acceleration of a body going through distance x, or going, for example, if this is the acceleration of a body in a time x, so a times dt from ta till tb is equal to the velocity at tb minus velocity at ta. That is actually the fundamental theorem of calculus. In other words, the dx cancels with dx and we get df, and df is f of b minus f of a. Let us see how the fundamental theorem of calculus gives us values of different integral functions. Imagine we write this fundamental theorem of calculus as df by dx into dx is equal to f of x. I want to see that which function x square is the integral of. In other words, what will be that function which I integrate and I would get x square. So f of x I'll put as x square. The df by dx is 2x. So this will be 2x dx. The integral of 2x is equal to x square. This tells us that both integral and differentials are inverse of each other, because if integral is x square, then the differential is 2x. The final question which one might ask about vector calculus is that how is it relevant to advanced structural mechanics? So the answer is, as calculus deals with the study of rates of changes and accumulation of quantities, in structure mechanics we are interested in internal forces, internal displacements, strains and stresses. We divide a body into very small elements. After that, we take one element of reference and try to find out all the internal effects. After that, we try to find out the rate of change of stresses and strains within a body. Sometimes we are interested in the accumulation of stresses within a surface, or we try to sum up all the stresses within a surface and find out force. Thus, the vector calculus, which deals with rate of changes and accumulation, help us in trying to understand the concepts of stresses and strain within the body.